In this video, we're going to prove the binomial theorem. The binomial theorem states that a plus b to the n is the summation as k goes from 0 to n of n choose k, a to the n minus k, b to the k. Now, before we get into the proof, there's a lemma that we're going to use. N choose R. So we have n objects. First object, second object, third object, all the way up to the n plus first object and the nth object. And I'm going to break this up. I'm going to break up this number into two parts. Parts that include n, this n, or any other number for that matter, and does not include that number. Well, if it does include that number and we want to choose R, but we already chosen one of the numbers, we have to choose n minus 1 remaining numbers. And we're going to choose them from here. You're not going to include n in the choice because we said you already chose n. So we're going to choose from n minus 1. Now, if you don't choose n, well, you have to choose all R. You didn't choose any, so you have to choose all R. And once again, you're going to choose the R objects from n minus 1. Let me just clean this up a little bit. And here is the lemma that we will use. Okay. We're going to prove this by induction on n, the power. We'll prove it by n. Well, a plus b to the first by this rule, so n is 1. So n is 1, n is 1, n is 1. We have the summation as k goes from 0 to 1, put a question mark there, of 1 choose k times a to the 1 minus k times b to the k. Well, when k is 0, this becomes 1 choose 0, a to the 1 minus 1, which is 0, b to the k, k is 0. 1 minus 0 for the power of a, and b to the 0 because k is 0. 1 choose 1 is 1. 1 minus 0 is 1. And b to the 0 is 1. This is a plus, now k is 2. Plus, k is the second number. I meant to say k is 1. First k is 0. This is where k is 0. Now k is going to be 1. So we have from this piece 1 choose 1, a to the 1 minus k, where k is 1, times b to the k, where k is now 1. Well, 1 choose 1 is 1. 1 to the 0 is 1 times b to the 1. Well, that's b to the 1. Plus 1 choose 0 is 1. 1 minus 0 is 1. A to the 1 times b to the 0, which is 1. Well, that's a. A to the 1. So we did get it. A plus b to the first is a plus b to the first. Wonderful. Now, we assume for, say, n is equal to m, that a plus b to the m is the summation as k goes from 0 to m of m choose k, a to the m minus k, b to the k. we assume this is true. We know it's true for n equal 1. Now, we want to show for n equals 1 more than m. So all I'm going to do is replace all these m's with m plus 1. Initially, I replaced all the n's with m. Now I'm going to replace all the n's with n plus 1. So we have a plus b to the nth power, which we'll call n plus 1, is equal to the summation as k goes to 0 to n plus 1 of n plus 1 choose k, a to the n plus 1 minus k, b to the k. This is what we want to show. We want to show that this is true, and we're allowed to use our assumption. Okay, so let us start off with this. And our goal is to show it equals the right side. Well, a plus b to the m. I just want to see one quick thing. Okay, I really should write proof. This is to plus 1. This is a plus b times a plus b to the m. Now that's a reasonable step to make because we can talk about a plus b to the m. So this is a plus b and times a plus b to the m is the sum, is our assumption. We're going to assume that it's the summation as k goes from 0 to m of m choose k, a to the m minus k, b to the k. Distributing, we get a times that summation plus b times that summation. We get a times this summation, which isn't going to change, okay, plus b times the summation, just their normal distributive law. Now, if a involved k's, I couldn't bring it in because this here would say k is constant. Only here k is changing, but let's not worry about that. A. Now, now I guess I should say it. The a plus b was never inside the summation, but now I want to bring it in. This is the summation as k goes to 0 of m choose k. I'll multiply that factor by a to the m minus k plus 1 b to the k. Remember, if you have 2 times 3 times 4 times 5, you do not multiply each of those numbers by 2. I mean, after all, this is 60. 2 times 60 is 120. You multiply 1. If you don't want to do what's inside first, you multiply one of the numbers by 2. So this is 3 times 8 times 5. That's 40. And look at this. 3 times 40 is the 120. I'm going to do the same to the other sum. I'm going to distribute the b. So we get a to the m minus k, b to the k plus 1, and k is going from 0 to m. Okay. Now what I'm going to do is I'm going to break off the first value of k. K is 0. So if k is 0, this mess would be just that, because m choose 0 is 1, b to the 0 is 1, and we're multiplying these. So it's just a to the m plus 1 plus the summation is k goes from 1 now to m of m choose k, a to the m minus k plus 1, b to the k. All I did was break off the first term. That's why now I'm going from 1 to m. And that's the first, that's when k equals 1. That's what this equals when k equals 1. Now over here, I'm going to break off the m's term. So you go, k is m. So you have m choose m, a to the m minus k is m, b to the k plus 1. That's 1. That's 1, a to the 0, which is 1, times b to the k plus 1, which is b to the k plus 1. So now I have to add on the rest of the terms. The terms that go from k equals 0 to m minus 1. M choose k, a to the m minus k, b to the k plus 1. Now, I would love for both summations to say go from 1 to m. Well, they're starting 1, this starts 1 less than 1, and this finishes 1 less than 1. We can play games with that. Okay, but first, we have a to the m plus 1, plus b to the m plus 1, let's bracket that, plus this first summation as k goes from 1 to m of m choose k, a to the m minus or k plus 1, times b to the k. I already brought that out in front. Now, if I let j minus 1 equal k, what does j start at? Well, we know this is the same as j is equal to k plus 1. Well, if k starts at 0, that is, forget that. That might be too complicated. If k starts at 0, we want j to start at 1. And if k finishes at m minus 1, and j minus 1 is k, that means j minus 1 is m minus 1. That means it ends at m. So I end at m. Notice I'm going from 1 to m. Now, let me just write above that, we're letting j minus 1 be k. Okay, so plus the summation, we argue the limits go from 1 to m. And here we're going to have m and j minus 1 for k. A to the m minus k. Well, m minus that will be m minus j plus 1, or m plus 1 minus j. Oh, okay. Let me say it the other way. M minus j plus 1. And then we have b to their k plus 1. Well, if j minus 1 is k, if I add 1 to both sides, then k plus 1 is j. Okay. Now, we're done. We're really done. Because now over here, since j is a dummy variable, believe it or not, I'm going to say let j become k again. Let j become k. So I have a to the m plus 1 plus b to the m plus 1 plus the summation as k goes from 1 to m of m choose k of this. A to the m minus k plus 1 times b to the k plus this where j is now k. So the summation as k goes from 1 to m choose k minus 1, a to the m minus k plus 1, b to the k. But look at this. This here is the same, and the summations are together. That is, this is nothing more than a to the m plus 1 plus b to the m plus 1 plus the summation as k goes from 1 to m of this plus that. M choose k, a to the m minus k plus 1, b to the k, plus this. M choose k minus 1, a to the m minus k plus 1, b to the k. But what's in here and here is something in common. This is a to the m plus 1 plus b to the m plus 1 plus the summation of m choose k plus m choose k minus 1. That times what's common. Okay, now remember that n choose r. So, we have 1, 2, up to n minus 1, and then n. Either we do choose n, which means we only have to choose r minus 1 more items or objects, and we're going to choose them from n minus 1. Or we don't choose n. That means we better choose r elements from the n minus 1. Okay. Now, notice in the bottom I have k and k minus 1. That matches up here. I have some number and one less. And the tops have to be the same. That's just what I have. Well, what happened is the top becomes one more, and the bottom we keep the larger one. Oh, k. So that's just k m plus 1 choose k. So this is equal to a to the m plus 1 plus b to the m plus 1 plus the summation as k goes from 1 to m. That's what we had up there. K goes from 1 to m of this sum, which is m plus 1 choose k, times a to the m minus k plus 1 b to the k. Okay. But I ultimately want this to be from k equals 0 to m plus 1. Well, what would this be when k equals 0? So you'd have m plus 1 choose 0, a to the m minus 0 plus 1 times b to the 0. Well, that's 1, that's 1. We get a to the m plus 1. But wait a minute, that's what we have here. If we add this and this, there's still the b to the m plus 1. We can't forget that. When I add what I underlined, I'm allowed now to start at 0 because I just added the 0 to this by adding on the a to the m plus 1. Okay, now I do want to do one thing before we get caught up. M minus k plus 1 is the same as n plus 1 minus k. And that's what I'm going to put right above. m plus 1 minus k. Now, I really don't want to, I want to start at 0. That's really good. But I don't want to end at m. I want to end at m plus 1. How great it would be if I replace k with m plus 1 and I got b to the m plus 1. So this will become n plus 1, choose. So this is where k is m plus 1. We get m plus 1, choose n plus 1, a to the m plus 1 minus k, which is m plus 1, times b to k, which is m plus 1. Well, this is 1. This exponent is 0. A to the 0 is 1 times b to the m plus 1. How lucky can we be? The m plus term right here is b to the k, b to the m plus 1. So I'm going to add that in. And I will get, the summation as k goes from 0 to m plus 1 of this. M plus 1, choose k, a to the m plus 1 minus k, b to the k. But that's exactly what I wanted. This is exactly what I wanted. And more importantly, it equals this. That is, we showed that a plus b to the m plus 1 is the summation as k goes from 0 to m plus 1 of m plus 1, choose k, a to the m plus 1 minus k, b to the k, which is this right here. That completes this proof, or 22-minute proof. If you like proofs like this, if you're into pure or theoretical mathematics, please subscribe to my channel as I upload videos like this every day. Also leave a comment, especially if you hate my videos. If you like it, leave a comment as well. Thank you.